Your brain is constantly pulsing with electrical rhythms, and neuroscientists have known this for a century. But the big mystery has always been why? What's with all that constant humming? Well, let's dive right in because it looks like we finally have an answer. And honestly, it might change everything we thought we knew about how the mind works.
So the real puzzle isn't that these rhythms exist. It's what are they for? For the longest time, a lot of people just thought it was noise, the brain's engine just humming in the background. But it turns out the truth is so much cooler than that. These rhythms, they're the very system the brain uses to organize time itself.
To really get this, you first have to realize that the brain's rhythm isn't just one single note. It's more like a full orchestra, a whole spectrum of different frequencies all playing together. So let's meet the main characters in this orchestra, starting with the speediest one.
Okay, first up, meet gamma. These waves are incredibly fast. We're talking a cycle that lasts just 10 to 30 milliseconds. Gamma is all about the right now. It's handling that fire hose of sensory information hitting you every single instant. The flicker of light, the texture of a surface. Think of gamma as your brain's high-speed processor for what is happening this very moment. Next, we've got theta. It's a bit more chill, a bit slower, with each cycle taking about a quarter of a second. Theta isn't just looking at single moments, it's stringing them together into a sequence. This is the rhythm of context. When you're remembering the steps to do something or finding your way through a place you know, that's theta, organizing that flow and telling you what usually happens here. And finally, we get to delta. This is the slowest, deepest rhythm of them all. We're talking cycles that can last up to 2 full seconds. Delta is working on a completely different time scale. This isn't about what's happening now or even what's coming next. No, this is the rhythm of who I am. It's the bedrock of our core beliefs and our very sense of self. So we have these different speeds, right? Fast, medium, and slow. And this is not random at all. In fact, this is the core insight of this entire way of thinking. These different speeds are the absolute key to how your brain builds your entire reality. And the insight is so simple, but it's really profound. It's just this. The frequency of a brainwave lines up perfectly with the timescale of the information it's handling. Fast frequencies deal with fast-changing stuff. Slow frequencies deal with slow-changing stuff. It's this beautiful, elegant hierarchy of time.
And boom, this is where it all just clicks into place. You can see how this whole system maps directly onto our own experience. Up top, you've got the fast gamma rhythms. They're asking, what is happening right now? In the middle, the slower theta rhythms are managing context, asking what usually happens here. And then at the very foundation, the super slow delta rhythms are holding on to the answer to, who am I? Your entire sense of reality is built right here in this stack of rhythms.
But okay, how do these different levels actually talk to each other? A fast gamma rhythm processing some little detail needs to know about the bigger picture, the context from theta. This is where that orchestra metaphor really shines. They don't just play next to each other, they're perfectly coordinated.
This coordination has a name. It's called cross-frequency coupling. And the best way to think about it is that the slow wave is like the conductor. Its own rise and fall tells the faster waves exactly when they're allowed to play their part. This is how details get nested inside their context. It's a brilliant system. And get this. It might even explain the famous 7 ± 2 rule for working memory. The number of things you can hold in your mind at once might just be the number of little gamma packets that can physically fit inside a single larger theta wave. Wild, right?
And this whole nesting thing is just computationally genius. It lets the brain do 2 critical things at once. Hold the big picture context with the slow waves, and at the same time, process all the tiny, fast-changing details with the fast waves, all without the signals getting jammed or interfering with each other. Now, it gets even cooler when we connect this to how the brain makes predictions. So your brain is always juggling 2 kinds of information. You've got the news coming up from your senses, all the surprising, unexpected stuff. And then you have your predictions coming down from your memories, what you expect to happen. The amazing part is the brain uses different frequencies for each job. The surprising news, the prediction errors, travels on the super fast gamma frequency. But your predictions, they travel down on slower alpha and beta frequencies. It's like having 2 separate radio channels to make sure the messages never get crossed. And as the legendary neuroscientist Georgi Buzjaki said, this isn't just some neat trick. This kind of timing, driven by oscillations, is the brain's fundamental organizer. It's basically the operating system that everything else runs on. So you might be wondering, why go through all this trouble? Why build this incredibly complex, multi-layered, multi-frequency system? Well, because it solves one of the most fundamental problems that any intelligent being has to deal with. And that problem is this.
How do you stay you? How can you hold on to a stable sense of who you are, your core beliefs, your identity, while also being flexible enough to react and adapt to a world that is literally changing every single moment? It's a huge dilemma, how to be both stable and plastic at the same time.
And the answer is just so elegant. The brain's solution is to use different clock speeds for different parts of the problem. You don't use one clock for everything. You use a whole range of them. So here's how that brilliant three-frequency solution works in practice. First, your stable sense of self is locked into those slow-as-molasses delta waves. Their slow clock speed protects your identity from getting tossed around by every little bit of sensory noise. Second, your flexible grasp of context is handled by the mid-speed theta waves, letting your habits and expectations adapt over seconds as you learn. And third, your immediate perception is all handled by those lightning-fast gamma waves, letting you react instantly to whatever the world throws at you. It is just a beautiful, multi-layered solution to a really deep problem.
So we've seen how the brain's frequencies have totally mastered the organization of time, creating this amazing system that's both rock solid and totally adaptive. But this is only one part of the story. There's another huge piece of the puzzle we haven't even talked about yet. This whole rhythmic architecture. This is how the brain masters time. We know that other parts of the brain structure handle the relationships between things. But for a truly intelligent mind, there's still a missing ingredient, maybe the most crucial one of all, the system's ability to create a model of itself. And exploring that strange loop is exactly where we're headed next.